Hello and welcome to lesson 5.2 on logarithmic functions. So last class we covered exponential functions. And now we're moving into what's called logarithmic functions. Well, what are logarithmic functions? Before I answer that question, I'll ask you another question. Do you remember what inverse functions are? Those are functions that are kind of perfect opposites to each other or undo each other. And remember, you could take a function and try to construct its inverse, right? The way you would do that is take your function. It's easier if you let y represent that instead of a function notation. And it's just some simple steps. Swap the x and y, and then try to solve for the y. Well, the problem is we don't really have a way to solve for this y yet in this course. And so that's where they invented logarithmic functions. So they said, okay, we're going to have a way kind of to handle this. And the way we're going to handle this is we're going to say, okay, log base 3 with with the input and the output kind of switch spots, okay? So input in x equals y. And so exponential functions and logarithmic functions are inverses of each other. And the reason that we have logarithmic functions are to be able to handle something like this, to be able to solve for y. Okay? Now, instead of calling it y, we'll call it f of x or f inverse of x. You don't really need to know all this that much detail. Just know that this inverse functions with exponentials. The main important thing is being able to switch back and forth between this relationship. So I'm going to write it a little more clearly and a little bit more explicitly. Okay, so if I do have a logarithmic function, it's going to have some sort of base, and it's going to take an input. This can be a number, a variable, okay? And that'll equal the output. We just got to remember that I can swap back and forth. Let me label these pieces. So that's the base of the log function. This is the input, okay? And then this is the output. I can interchange this with, guess what? This 2 was the base of the log function. It's also going to be the base of an exponential. And then instead of having the input and output, they kind of swap places. I have y up here as the input, or I could think of it as just an exponent. And that would be equal to x, or the output. Okay, so I need to be able to swap back and forth between these two notations. Why? That seems weird and stupid. I'll show you some examples of why we'd like to be able to do this. Because without using a calculator or anything, it's really hard to calculate some of these logarithmic functions. So if I give you something like this, I need you to be able to figure out what its value is. So we're going to start with just evaluating these or finding the value as a few examples. We'll get into much more interesting things because these logarithmic functions have special properties, and we'll teach you those over the next few lessons. So find the value of this. Well, just remember that I can rewrite this. I can rewrite it where, okay, what's the base? The base is 4. That'll be the base of my exponential. And we're going to swap. Well, I don't have anything here. Let's just call it x. Okay, since I don't know I'm looking for it, we're going to find this x. Swap 16 and x. And so x would go up here. 16 would be the output. And now I have exactly the same type of problem that I taught you to solve last class. You look at this and you say, can I get them to the same base? And you're like, oh, 16 can be written as 4 squared. Same bases are equal, so that must mean that the exponents are equal, and x equals 2. Oh, wait. So thus, we know that the log base 4 of 16 is equal to 2. We found the answer. We were able to find the value of that. And we can do a few more. Well, let's not waste a bunch of time on this. Let's do one more like that. Find the value of this one. Log base. Nope. Copying the wrong example down. So we'll go log base 9 with an input of 3. And some people put these in parentheses, some people don't. And I want to find the value of that. So we're going to rewrite it. So the base is 9. I don't know what this is. I'm going to call it x. And so the input and output switch places. And it's equal to 3. Okay. I can't get 3 to be a base of 9, but I can get 9 to be a base of 3. 9 is 3 squared. With this x still out there. And this is exactly the lesson we did last time, was being able to do this. Okay, the 2 and the x multiply, so I have 3 to the 2x equals 3. Now there's no exponent showing here, but if there's no exponent showing, we know that's understood to be a 1. And so the bases are equal, therefore the exponents must be equal, so 2x must equal 1. And now we have a very simple equation to solve. Divide by 2, and x is 1/2. So what does that mean? That means, thus, the log base 9 of 3 is 1/2. So we can evaluate logs being able to do this little conversion. Now this also is a handy way for solving for x, depending on where we plop this x. But let's say that I have log base 5 of x is equal to 3. And I want you to solve for x. Well, we're just going to take the time to rewrite this. What's the base? The base is 5 as an exponential. Swap, let's see. So this will be to the third equals x. Oh, this is easy. I'm not even solving anything. 5 to the third is 125. So x is 125. That's super easy. So if the x is here, rewrite it, it's going to be a piece of cake. What if the x is somewhere else? Well, we did basically with x here, trying to figure it out. X here, what if the x is the base? So let's solve for x this time. Let's say I have log base x of 25 equals 2. Well, once again, it seems like it's a good idea to go ahead and just rewrite these to be able to solve them. The base is x, and then the exponent will be 2, and this will equal 25. Oh, well, this is just a quadratic. We learned to solve these a few chapters ago. To get rid of the square, I can square root both sides, and so x will equal, we will say 5 here, but usually wouldn't we do positive 5 and negative 5? But there's something wrong with these negatives, and let me show you that really quickly. So let's actually graph a logarithmic function, okay? Where is my graphing calculator? That's my plain calculator. So let's just graph something like y equals the log base 5 of x. This is what it looks like right here. It's very similar to an exponential because it's the inverse function to an exponential. Notice that this doesn't dip back into the negatives. If you're tracing with your finger, instead of having a horizontal asymptote, this has a vertical asymptote that it can't cross, and it cannot take any negative values. So we found a positive value and a negative value. We have to throw out the negative values whenever we do those. So if I get one like this and I square root to solve, one of these is bad. So 5 is the answer. X equals 5. Okay? So now, there's a bunch of, when I say a bunch, there's a list of properties we're going to study. I'm going to save the big ones for next lesson. For the rest of this lesson, we're just going to touch on 3 very simple, I'll call them quick properties about logs. Okay, so these are a few properties. We'll hit some bigger properties next lesson. This lesson is got some pretty simple ones. So 3 quick properties. The first one is, no matter what the base is, if you have an input of 1, your log is going to equal 0. Now, let's do some thinking as to why. If you were to rewrite that, the base, no matter what it was, would have an exponent of 0. Of course, that always equals 1. The only way that this is going to, work out, if you have well, let me rephrase it. If you have an exponent of 0, you're going to have an output of 1. And so when you have a 1 here, you're going to have an output of 0 in your log function. Okay, so next property. The next property says if you take a logarithm and you have a base, and then you have the same like input as the base, and you have some value up here. It doesn't matter. Let's just say 7. Whatever the exponent on this input is, that's going to be your answer. Now, why would that be the case? If I were to rewrite this, imagine what you're going to have here. You're going to have this base raised to this exponent, right? So you'd have b to the 7th equal to whatever this is. Well, the only way that this will be equal to the it's going to, if it's written as a base and an exponent, it's got to be identical, right? So if these two things are the same, if this has any exponent, that's just what the output's going to be. Okay. And then the third property, these quick properties, if I happen to have some base and I'm writing an exponential function where the exponent is a logarithmic function, so I start to mix up a few things here and make it look really difficult, but it's not, and it has the same base as the exponential base. Whatever I have here, let's do 13, whatever I put in as the input, that's what I'm going to get as the answer. Why is that? Oh, well, if you did a whole rewrite on this and figured it out, you would you get the same thing. But the main reason that 2 and 3 work is because of what I explained to you earlier, that exponential and logarithmic functions are inverse functions. So when you plug it, this is an exponential type thing inside of a logarithmic, and they have the same bases, they undo each other. This is a logarithmic type thing inside of an exponential function, and they have the same bases, they undo each other, and you just get pieces back. So let's actually use these properties really quickly, or show you how these properties are kind of used. So I may ask you to evaluate something like the log base 3 of 1. And hopefully right away you know the answer, because if I have a log of any base of 1, oh, that's just going to equal 0. That's that first property. Okay. Or if I say, okay, find me the log of base 3, and I'm going to plug into it 3 to the 5th. And you say, look, I have an exponential thing inside of a logarithmic thing with the same basis. It's just going to cancel it. I'm just going to get 5 back. The answer is going to be 5. That's that second property. And finally, that third property, if I have something like 5, and I raise it to the exponent of log base 5 of 7, I know the answer for that as well, because this exponential thing is just going to undo this log thing. They have the same basis. Now we'll just get an answer of 7. So you could have some very simple things to calculate just from knowing these properties. And you can build much bigger things in higher level math by knowing these properties is very important. We'll hit some more deeply thoughtful properties, or I don't even know how I want to word it, later in this chapter, or some more interesting properties, I guess we'll say. Actually, the very next lesson, we'll hit some better properties. Okay? But that's all I have for you. Good luck with the homework, and give me an email if you have any questions.